Question. Rocks is one of the harder questions you're going to see. So let's walk ourselves through this, because you've got a rocket launched straight up with a constant acceleration. 4 seconds after liftoff, the bolt falls off. It hits the ground. What was the rocket's acceleration? So let's think about this. So you've got a rocket that's taking off. Okay, it's a rocket. It's shooting stuff out. Okay, I don't know. This is your rocket. So you got a rocket, and at 4 seconds, a bolt falls to the ground. But it was accelerating at a certain speed. And so we're going to have to do several problems here. So let's talk about our rocket. Rocket first, let's talk about the bolt later. Make sense? So y1 of the rocket, right? He starts off, y1 equals 0, right? y2 is, well, we don't know that. We're going to need to find that, though. We know what is the v1 of the rocket, right? Initially, he was at rest, so that's 0. v2, we don't know that either. What is his? Because the trick on this problem is that it's not just falling, it's actually it's going up with a certain speed, and then it's going to fall back down, the bolt. And so I need to find this v1. This v1 is critical. And it turns out I'll need to know what the y2 is, too. I got to find these, not the v1, the v2, pardon me. I need to find out what these two are, or game's over, right? In A, which is the big question, right? This is the big question. What is the acceleration? But we do have a time. So the time that we have, of course, now from the perspective of the rocket, is 4 seconds. So for the rocket, I can say y2 equals y1 plus v1t plus 1/2 at squared. Now, I am going to plug in what I know and watch what I do. I can say that y2 equals y1. y1 is 0 plus 0. That's easy. These two just drop off, don't they? Because the v1 is 0. So it's plus 1/2 times a times t, and t is 4 squared. Now, 4 squared is 16. 16 divided by 2 is 8. So I can say y2 is equal to 8a. I'm going to actually leave it with the a there. I know that we want it to be an actual number, but we need to say, no, it's just 8a. Then what I'm going to do is I need to then find what v2 is. So what is this v2 here? So I need to find this v2, and I need to leave it in variable form. So what I'm going to have to then do is the equation there is v2 equals v1 plus at. Well, v1 is 0, so I can say this is just equal to a, and what's my t? 4, or I can say 4a. So this is v2. So now I know, all right, and now I don't have the exact number, but I have it's either 4a or 8a. So the v2 is 4a, the y2 is 8a. Okay? Now we want to look at it now from the perspective of the bolt. So down here, now let's talk about the bolt man. So for the bolt, what is y1? Now he's starting up here, right here at the top, right? So his y1 is the y2 of the rocket. So y1 is 8a. Making sense? y2, now that's easy. The bolt's going to fall to the ground. That's 0. v1, now the v1 of the bolt is the v2 of the rocket, so that is 4a. The acceleration, now we're dealing with it, now it's just falling, right? So the acceleration, we know this, is negative 9.8. And this, it takes 6 seconds for it to fall. So now what I do is I plug this into my equation. I can say y2 equals y1 plus v1t plus 1/2 at squared. All right, now y2 is 0 equals y1. Now y1 is 8a. Plus v1, which is 4a times the t here is 6 seconds, plus 1/2. Now the a in this case is not this a, This A is the A of the bolt, and that's around the Earth, so it's negative 9.8 times 6 squared. And now we have an equation where we have A's and numbers, and we can now simplify this and solve for A. And that will be the A, right? The A of this A up here in the top equation, the rocket perspective. Because the question, what's the acceleration of the rocket?